Alright guys, now we are going to go over the second problem on TopCoder SRM 800. It's just another live stream. I actually can't do another problem. I can't do problems today, so that's why I'm doing this other live stream. And if I'm going to record it anyway, might as well do a live stream. But yeah, so what is this problem statement? This problem statement is a little more tricky to understand. But if you understand the gist of it, it's actually not that hard to simulate it because it's just a simulation problem. Okay, so basically you have like slot machines that has like a bunch of characters, right? You play the game by inserting a coin and pulling a lever. So once you like pull, insert a, once you put a coin in it and pull the lever, it gets added by a number of steps, right? So like the slot machine that has a bunch of characters get added by a number of steps, and that's given in a step array. So like if you, let's say you have hold up. Why can't I minimize this? Okay. So let's say you have this ABC, ACB, CAB, right? If the slot is 32, right? That means, and I start from initial character, I start at A, right? It's going to add 32 to the initial index of 0, right? And then it's going to basically, each time you step through, it's going to go to the next character in your string. So it goes to B, then it goes to C. And then after C gets added, right, it comes back to A, right? So that's what this slot machine is. So like every time I do something, it pushes the index that you're currently at. You add a certain number of indexes to it. Okay. You add a certain number of steps, and that step is given by this index. Okay. And but the steps are different for each of them, right? So like for this slot machine, ACB, if I add 31, right, it's gonna add 31 to my first starting index of 0, and it's going to keep you going that. And then after the cycle, it goes back to A, right? So depending on what step you have, what step you're adding, it would go to a different character based on your string that you have. So it depends on your increments of what step you have and what your current string character is. And it would just recycle back in the beginning. Okay, so that's basically just the problem. Now, what they want us to do is that they want us to get all C's, right? So C represents the cherry, and all the other characters are fruits. So we want to get all these. We want our last string to have is all C's, okay? So so you have a number of steps. So now what we want to do is return the smallest number of integer, such that if you wait X games, you let other people like hit the steps, like push the coins in and hit the steps. So you want the minimum possible non-negative integer such that if you place the steps, a slot machine, you play a game, then he would win jackpot. So return -1 if it does not exist, right? So we want to see how many times does this guy want to do is to place a coin in and pull the lever and go into the steps. So we want to see how many steps it takes for each of them to get to C. So if you look at this initial one, right? Currently we have in the current one, right? The current slot machine, they always show the first characters. So given ABC, ACB, and CAB, given these characters, right? We start at A and C, right? We start at A. We always start at the first character. So the first characters are always A, C, right? Basically, every time we hit the slot machine, we are going to add by a number of steps. So the first one it's going to add is by 32 steps. So it's going to add by 32 steps. Second one's going to add by 31 steps, and the third one adds by 30 steps based on the array, right? So apparently, if you were to add by 32 So if you just do nothing and you hit the slot machine once, right, you're actually going to get all C's. And I'll show you why. Because if you were to add by 32 and starting the index of 0, right, and add by 32, it's going to cycle through and it's going to come to C. And how do we know it's going to cycle through? Because if you take 32 and you mod by the length of the string of 3, so 32 mod by 3, right, that's going to give you 2, right? So it's going to give you 2. And that's based on the position of the string 0, 1, 2, it's C, right? And if I take 31 mod by 3, which is the length of this string, so I take 31 mod by 3, this is going to give me 1, 0, 1, right? And that's this C, right? So this is going to give me this C. So I get C, C. And if I take 30 mod by 3, I'm going to get 0, which is this C, and I have a C here. So in the end, I'm going to have all C's. So that's why if you just do like one step and add by each of these corresponding steps, you're just going to get, it would just take 0. You just wait 0, right? So basically we want to get the steps minus 1, basically. But yeah, you don't have to do anything, because if you just do one step, then like have another person play it once for each of these, you'll end up with all C's. So that's why the answer they give you is, answer for this is 0, right? Because if you just have them play, add just each of these one steps, you'll end up with 0 with all C's. So that's why the answer is 0. But so basically the gist of this problem, to solve this problem, is that you need indexes for all of these characters, right? For the character that you're currently at. So what I did was I created an index for each of these characters. So the first indexes, remember, they always start at 0. So you create an index for each of these characters that you're going through. So like initially it would start from 0, 0 and 0, right? 0, 0, 0, 0, 0, 0, 0. So this is where it would all start from. And what you want to do is basically every time you add, what you're going to do is you're going to loop through them, and you're going to add by the corresponding steps. So 31 to 30 and 32, right? And whenever you add by the corresponding steps, you're going to take modulus by the length of the string so that it would recycle back to the original character that you're at, right? So like if I go to the next character, go to +1, it goes to B, right? And then C, then it comes back at A. So that will tell you the last position of your character that you're currently on, right? So if you do that for all of these, you're going to end up getting a string of characters, right? You concatenate it to a string, you're going to get a bunch of characters. So you're, in this case, if I just do it once, I'm going to get all C's, right? So once you have all the strings, the characters that you did it for all these values, you just have to check if they're all equal to C. And then if they are all equal to C, then you just return the counter that you had for the number of times you're doing this. So because of the implementations is really small, like the constraints are super small, you could just run this like 100,000 times, because based on the problem statements, you just have to run this 100,000 times, and then you'll end up with the values, the smallest value to return, right? Smallest value to return the number of steps that it takes. So now I'll just show you guys the code for it. Whoops. Yeah, I'll just show you guys the code right now. Okay, so here is the code that I did. So I actually failed the system test in the end because I didn't modulus correctly. But yeah, I was supposed to modulus correctly. But yeah, here we have the number, integer number is 0. This number represents the number of times we're going to have steps. We're going to put a coin in and then, change the slot machine and then add the steps for each of the values, right? I'm going to run this 100,000 times because the problem statement is only like, I think 10 to the 6 or something. So that's where we could just run this 100,000 times. Each time we just put in a slot machine for it. Okay. This string check is just going to be the number of characters that we want with all C's, right? So in the end, when we concatenate it to our string, in this case, we just have to check if they're all C's. And to check if it's all C's, you just have to check if it's equal to a bunch of C's, right? The answer is equal to a bunch of C's. So that's why I created a check, which is just a string that has a bunch of C's. So then we could, at the end of our answer, we just check if it's equal to this variable check. Okay, so I also created a variable for indexes for all these indexes, because that's basically the index for each string that you want for each of these characters, so that you increment by the steps for each of the steps, right? Okay, so while number of times is greater than 0, I'm going I have a while loop for that. So this is that means it runs 100,000 times, right? Okay, I create a string, empty string. And what do I do first? Okay, I'm going to loop through the number of reals, which is the number of strings here, right? So we have 3 strings. We're going to loop through all 3 strings, okay? Each time I loop through a string, I'm going to get the index. My current index is at the value. I'm going to add by the number of steps for that corresponding step. So here, it'll just take 0 plus 32. Yeah, and then after that, it'll take 0 plus 31 and then 0 plus 30, right? So for each of these strings. Then what I'm going to do is I'm going to modulus by the size of the string of the reals. So that's going to mod by 3. So we have ABC mod by 3. So then it would cycle back into the next character to add. That's what it would do. Okay, this integer index was just because I don't know why I created a variable. Technically, you don't even need it, but yeah. Then after that, I just concatenate the string with the corresponding character at the index, right? So in this case, at the ith string here, I would just concatenate it at the corresponding index. So this would actually add the single character C. This is going to add the single character C. This is going to add single character C. So at the corresponding index of I, I'm going to get the corresponding index that we added for each index. Okay. After that, we're going to be done with our string, right? String S is going to have all of the characters, all of these characters, right? I just check if it's equal to check. Check is just the length of string that has all C's, right? So I check if they're all C's. If they are, I just return number. So number is the number of times we're going through this simulation. So that I set number equal to 0 in the beginning. So if it's equal to the answer, I just return number. Otherwise, I have to increment our counter of number plus plus, because this is going to be the number of times we're actually going to put a coin into the machine and pull the next slot. Okay. And then after this, I do times minus minus, because we're running this 100,000 times. So within those times, it should be able to, sooner or later, it's going to at least get to a character, right? Sooner or later. At least if we run this 100,000 times, based on the constraints, sooner or later it has to get all the increments that it would do for each step. So that's why. So this is the case if you don't actually add if it's not equal to a bunch of C's. So that's why this is the case. So times minus minus. Okay, so at the end of times, if we ran the simulation 100,000 times and you still haven't gotten all C's, you just return -1, because at that point it's impossible, right? No matter what, if you run this 100,000 times and you can't get all C's for each of these characters you're going through, then just return -1, because that means it's not possible. But yeah, that's basically the gist of the code. I hope you guys understand this. Rate, comment, subscribe. I'm going to actually have to go and do some homework now, so I'll check you guys later. Anyway, peace.